Hi, everyone, welcome to my channel again. Today, I am going to share about predictive maintenance. Before watching, please like, comment and subscribe to my channel. Your support will encourage me to produce more videos related to Lean Six Sigma and operation management. Predictive maintenance is perhaps the most misunderstood and misused of all the plant improvement programs. Most users define it as a means to prevent catastrophic failure of critical rotating machinery. Others define predictive maintenance as a maintenance scheduling tool that uses vibration and infrared or lubricating oil analysis data to determine the need for corrective maintenance actions. Because of these misconceptions, the majority of established predictive maintenance programs have not been able to achieve a marked decrease in maintenance costs or a measurable improvement in overall plant performance. Predictive maintenance is much more than a maintenance scheduling tool and should not be restricted to maintenance management. Definition of predictive maintenance: predictive maintenance is a management technique that, simply stated, uses regular evaluation of the actual operating condition of plant equipment, production systems, and plant management functions to optimize total plant operation. The output of a predictive maintenance program is data. A comprehensive predictive maintenance management program uses the most cost-effective tools such as vibration monitoring, thermography, tribology and other to obtain the actual operating condition of critical plant systems, and based on this actual data schedules all maintenance activities on an as-needed basis. As a maintenance management tool, predictive maintenance can provide the data required to schedule both preventive and corrective maintenance tasks on an as-needed basis. Instead of relying on industrial average life statistics, such as mean time to failure, to schedule maintenance activities, predictive maintenance uses direct monitoring of the operating condition, system efficiency, and other indicators to determine the actual mean time to failure or loss of efficiency for each machine train and system within the plant. At best, traditional time-driven methods provide a guideline to normal machine train lifespans. The final decision, in preventive or run-to-failure programs, on when to repair or rebuild a machine must be made on the basis of intuition and the personal experience of the maintenance manager. The addition of a comprehensive predictive maintenance program can and will provide factual data that define the actual mechanical condition of each machine train and operating efficiency of each process system. These data provide the maintenance manager with factual data that can be used to schedule maintenance activities. A predictive of all mechanical equipment in the plant and ensure that repaired equipment is in acceptable mechanical condition. The program can also identify machine train problems before they become serious. Most problems can be minimized if they are detected and repaired early. Normal mechanical failure modes degrade at a speed directly proportional to their severity. If the problem is detected early, major repairs, in most instances, can be prevented. Predictive maintenance techniques: there are a variety of technologies that can and should be used as part of a comprehensive predictive maintenance program. Since mechanical systems or machines account for the majority of plant equipment, vibration monitoring is generally the key component of most predictive maintenance programs. However, vibration monitoring cannot provide all of the information that will be required for a successful predictive maintenance program. This technique is limited to monitoring the mechanical condition and not other critical parameters required to maintain reliability and efficiency of machinery. It is a very limited tool for monitoring critical process and machinery efficiencies and other parameters that can severely limit productivity and product quality. Hence, as previously noted, it must be iterated that a comprehensive predictive maintenance program must include other monitoring and diagnostic techniques. These techniques include 1. Vibration monitoring, 2. Thermography, 3. Tribology, 4. Process parameters, 5. Visual inspection, and 6. Other non-destructive testing techniques. Most comprehensive predictive maintenance programs use vibration analysis as the primary tool. Because most normal plant equipment is mechanical, vibration monitoring provides the best tool for routine monitoring and identification of incipient problems. However, vibration analysis does not provide the data required on electrical equipment, areas of heat loss, condition of lubricating oil, or other parameters that should be included in your program. Thanks for watching. Remember to subscribe to my channel. Bye, see you next time.